All right, so we're able to figure out the answers to these questions. Should a 12-inch by 10-inch reducing tee be used when making a branch connection? Well, if we go back and take a look at our spec, branch connections 3 inches and above, stub in when less than line size. So we can use a stub in when we have a 10-inch going into a 12-inch because the 10-inch is less than the line size. So the answer is no. Will screwed or socket welded fittings be used on small bore pipe? Well, again, let's take a look at our spec. Fittings, small bore pipe, it's going to be 1.5 to 2 inch. Socket welded. What's the designated rating for 8-inch seamless pipe? So what pipe weight are we using in a system if we're using 8-inch? Well, again, pipe 3 to 24 inch, standard weight. What's the operating temperature for the spec? That'll be under conditions, temperature, operating, 275. And then finally, what fitting or fittings are going to be used to make a 1-inch branch connection on a 2-inch pipe? Well, our specification class answers that too. Branch connections for 2 inches or below, it says use a T and a swedge on 2 inches and smaller. So T and swedge. What are the other things in that specification class that might be a new concept for you? Something different? Corrosion allowance, right? Because sometimes the material that's going through the commodity might be something that slowly wears away at the interior of the wall of the pipe over time, or it might be something that is corrosive, right? Like an acid or an alkali, some chemical that's going to wear away at the pipe material. So this says after 5/100ths of an inch of material are lost that we need to replace the pipe, the fitting, the piping component. And there's actually a machine, a UT machine, that's used to measure the thickness of the pipe wall, from the outside of the pipe. So this is something that's done in testing where a technician will go around and take critical measurements at different locations to make sure that the pipe wall interior hasn't been corroded away too much. And when it has, well, then it's time for replacement. Now, one of the things that we're going to see in this chapter about specifications is pipeline identification numbers. Okay, and we saw this on the P&ID. Now, you might not have understood what you were typing, but these codes that go on each one of these lines is the pipe identification number. And it's a multi-digit code with different components of numbers and letters, and we're going to talk about what do they mean. So, a very basic pipeline identification tag is going to include the line number, the specification, and the size. Okay, now sometimes big projects are broken into smaller components. Maybe we have a big facility and we're going to break it into 4 or 6 or 8 or 10 smaller units. So in that case, we have a unit number at the front, followed by the line number, the specification, and the size. And then this one here has 2 pieces of text added to the end. This is related to insulation. So IH means it's insulated for heat. IC, insulated because the commodity is cold. PP would mean that we are insulating the pipe to protect personnel that might be walking around it and bumping into it. Right? And then IS, insulated for safety reasons. So this is a extensively long full code, and some pipeline identification numbers will be even larger, but these are some basic components that we would see in a pipeline ID. If we take a look at some of these ID codes on this P&ID, we see this is Unit 1. This is pipeline number 11. It's an A15 spec. It's 6 inches nominal pipe size, and it's insulated for heat. Okay, so this is hot oil going into this reboiler. And then over here, coming out, we see it is still Unit 1, but this is pipeline number 10. It's still an A15 spec, but now it's a 6-inch line. It is also hot, so it's been insulated for heat. Could you identify what this means if we were to take a look at it? So this is on page 156 in your text. 04106 C30 8-inch PP. What does all that mean if we see that tag on a P&ID or on a pipe arrangement drawing? Well, doesn't 04 mean Unit 4? Right? So maybe we have a large facility. It's broken up into 4 parts, and this pipe spool is in Unit 4. 106 is the line number. And we might start with line 1, 2, 3, 4, or we might start at line 100 and go 100, 101, 102, 103, 104, because it's kind of hard to have a negative pipe number. It would be better if we have to add pipe numbers to be able to go down to 99, 98, 97, than to have something like -3. C30. C30, that was a specification class, wasn't it? That was 300-pound process pipe service carbon steel. 8-inch is the nominal pipe size, and PP, personnel protection, insulation wrapped around the pipes. So if you're able to discern all that, that's fantastic. Now, there are a lot of abbreviations involved in piping, and your text has a whole bunch of them for you to take a look at. Starting on page 166, you'll see abbreviations related to process piping drawings, and there are a ton of them. I really don't feel like there's a need for us to sit down and memorize a bunch of this stuff. Okay, this will come to you and you'll get familiarity with it if you spend some time working in the drafting field doing process pipe drafting drawings, right? So just understand they're there, and if you're looking for abbreviations, this is probably a good place to go take a look at. Won't lie though, sometimes abbreviations can get completely out of hand. For example, take a look at this abbreviation and see if you can figure out what it's short for. So that's an awful lot of letters and periods, right? So this was actually a note on a drawing, and I don't know who came up with the abbreviation. Sometimes people make them up themselves. This is supposed to mean angle brace, cut to suit, bare to fit, paint to match, ship to field, install at leisure. Somebody was really reaching when they came up with that abbreviation.